What if you traveled out of the solar system? What exactly constitutes a solar system? Well, aside from the obvious requirement of a star, a solar system consolidates more than just planets revolving around a ball of hydrogen and helium. Anything influenced by the star's gravitational pull is part of the system, and this includes asteroids, comets, meteoroids, and natural satellites. Estimated to be more than 4.5 billion years old, our sun breathes life into the wider solar system. While our corner of the universe is big enough to keep NASA busy for the foreseeable future, it's but one sliver of a larger galaxy known as the Milky Way. Technically, to us, there is only one solar system, as other clusters are referred to as stellar or star systems, but estimates suggest that there are approximately 200 billion stars in the Milky Way. The galaxy's almost incomprehensible size puts things into perspective, but the Milky Way is merely one small town. In fact, the Hubble telescope has established the existence of at least 100 billion galaxies. So how exactly is the universe structured? If someone were to leave the solar system, would they soon encounter a new collection of planets orbiting another ball of fire? Eventually, possibly, but not before some serious voyaging. Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. Collectively known as the interstellar medium, the space-separating star systems begins where a sun's magnetic field stops influencing its surroundings, and it chiefly consists of gas and dust. Because regardless of what it seems, space isn't truly a vacuum, although the density varies wildly from area to area. In the grand scheme of things, the solar system is minuscule. Nevertheless, human ingenuity has yet to advance far enough to allow for a safe voyage into interstellar space. Due to the vast distances being calculated, we use astronomical units to actually measure space, with 1 AU equivalent to the average gap between Earth and the Sun, which is approximately 93 million miles. Entering into only the first stretch of interstellar space means traveling farther than 120 AU, and even then the sun's gravitational pull continues to wield some effect for roughly another 100,000 units. Given that humans have made it to the moon but no further, with trips to other planets still seeming a far-off dream, getting people into interstellar space seems an impossible goal. However, while a manned shuttle isn't currently on the cards, 2 spacecraft have successfully crossed into the interstellar, Voyager 1 and 2. Launched in 1977, Voyager 1 has been flying away from the Sun towards the great unknown for decades. After completing its primary mission by 1980, conducting flybys of Jupiter, Saturn, and Titan, it just kept going and going, until in 2012 it became the first human-made spacecraft to enter the interstellar medium. 6 years later, Voyager 2 repeated the same staggering feat, although it's important to note that even these crafts have only actually left the heliosphere, which is essentially a bubble created by the sun's solar wind and not the entire solar system itself. Using Voyager 1 and 2 as blueprints, it'd take more than 30 years to travel the 11 billion odd miles necessary to reach the interstellar medium. But that's assuming the human body could somehow withstand the 38,000 miles per hour velocity sustained by Voyager 1. Say science does find a way for humans to complete such a journey though. What sights can an astronaut look forward to? Putting aside the technological process needed to amass the necessary momentum to actually leave the solar system, the route involves crossing the asteroid and Kuiper belts towards the heliosphere's outer layer. Ranging from Mars to Jupiter, the asteroid belt is unsurprisingly home to the majority of the solar system's asteroids. With the number of drifting stones in the thousands, you might think that this portion of the journey would coincide with quite a bit of turbulence. But luckily, the asteroids are dispersed over such a massive area that avoiding a direct hit should be fairly simple. The Kuiper belt covers the area past Neptune and alongside other dwarf planets includes Pluto. Like its predecessor, the Kuiper is sparsely littered with floating objects, although many tend to be frozen due to the sun's weakening rays once you get this far out. Following the belts, the spacecraft steadily begins to approach the heliosphere's outer layers. On average, Pluto is around 40 AU away from the sun, but the heliosphere stretches on for another 80 units. It's essentially a protective bubble created because our star exudes charged particles as solar wind, and the heliosphere is how far they stretch. Beyond this point, the sun does continue to exert a force on objects, but the particles are less densely packed, and the bubble breaks up, which takes us to perhaps the first significant roadblock on this ultimate road trip, a stream of gas known as the termination shock. This layer coincides with the sun's solar wind colliding with the interstellar wind on the other side. It's where the sun's influence truly starts to diminish. According to NASA, Voyager 1 crossed this threshold at approximately 94 AU. The termination shock leads into the heliosheath, which is the heliosphere's outermost layer. Theoretically, this area should be the most volatile of the lot, marking the point when the interstellar wind begins to match the sun's power, making conditions almost impossible to predict. Picture the solar system as a boat sailing across a sea of gas, and the heliosheath is the bow thrusting against the waves, taking most of the force. Finally, we reach the heliopause, which is the final border separating the heliosphere and interstellar space. At this point, the solar and interstellar winds emit equal but opposing pressures, causing the sun's particles to flip inwards towards their source of origin. It's a point of no return for most of anything linked to our solar system. With the heliopause in the rearview mirror, astronauts can look forward to drifting through empty, seemingly endless space before ultimately entering the solar system's true final layer, the Oort cloud. Believed to consist of comets requiring approximately 200 years to orbit the sun, astronomers believe the Oort cloud commences at a distance of 1,000 astronomical units from the sun and stretches on for approximately 100,000 units. If Voyager 1 required 35 years to leave the heliosphere, the spacecraft has to continue moving forward at the same speed for roughly another 250 years to reach the Oort cloud. By now, assuming that we A, somehow had the technology to take us this far, and B, had devised some way of stalling our natural aging process so that we're still alive by the time we break the Oort cloud, our minds and bodies will have gone through some major transformations. Earth's atmosphere protects against the sun's radiation, and an astronaut's body tends to weaken after only a couple of months away from the planet's surface. So in reaching the heliopause, astronauts would risk exposure to an immeasurable amount of radiation over an incredible time period. Even with some kind of radiation immunity medicines or technologies, and even though they would be steadily moving away from the sun, any interstellar astronaut will have had to have gone some form of adaptation to their surroundings. Throw into the mix infinitely heightened concerns over muscle atrophy and bone mass decline, inevitable challenges regarding mental health, and unknowable problems linked with the endless isolation, and you end up with a traveler almost unrecognizable from that which had set off. Assuming you somehow managed to enter interstellar space in one piece, the Oort cloud should take around 30,000 years to traverse. Of course, the painstaking commute could be avoided if we managed to develop a viable method of traveling at light speed. In fact, taking into account that the sun's rays need a bit more than 8 minutes to hit Earth, a shuttle traveling at the speed of light should be able to leave the entire solar system in less than 600 days. Whichever way you get there, with the solar system finally behind you, the question becomes, what's next? The Alpha Centauri system is adjacent to ours and houses 3 stars, with the red star Proxima Centauri being the closest. So that would be your next port of call. But here's hoping you're not running low on fuel and you're still somehow keeping old age at bay, because getting there, even at light speed, would take another 4 years. Travel at anything less than light speed and you're talking centuries. What would you see on the way? Unsurprisingly, we're low on first-hand accounts, but the light from Proxima Centauri would always be in your sights, growing brighter day by day. If humans ever were headed that way, then chances are they'd be beelining for the exoplanet Proxima Centauri b, as it's the closest exoplanet to us and it orbits within a potentially habitable zone. So if there's life outside of our solar system, then here would be a good bet to host our closest neighbors. And from there, if we've advanced enough as a species to survive such a monumental trip, then the entire universe is ours to explore. The Milky Way is, after all, simply one member in a cluster of large and dwarf galaxies. Andromeda is the nearest similarly sized galaxy to ours. So if we ever could go galaxy gallivanting, then we'd wind up in Andromedaean territories next. That said, Andromeda is estimated to be around 2.5 million light-years away from us, so we'd have to improve on even light-speed travel to stand even a slim chance of seeing it. Right now, it feels like the farthest of far-off dreams. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.